So what's the difference? The difference that we're going to see in these kind of problems, and I'm just going to jump right into an example because I already have all the identities that we're going to be using. So we're going to verify the following equation is true. Okay? So, first one we'll look at here, sine of theta plus cosine theta cotangent theta equals cosecant theta. So I'm going to verify sine theta plus cosine theta times cotangent theta is equal to cosecant theta. So the difference here, then, from what we saw, yesterday, is that we now have a goal. Our directions are not just to simplify, not like kind of the nebulous term simplify, right, and just like bring things down to a single term or whatever that might be, okay, cancel things out, that kind of thing. In this case, we want to verify that this is actually equal to this. Okay, and the steps in which we take, the steps that we use to do that are going to be very similar to what we did. Essentially, we're going to be trying to manipulate this side here to look like this, right here, cosecant of theta. So that's our goal. We want to take this and get it to equal cosecant of theta. Okay, which in a sense is just like simplifying, right? We kind of have two terms here, separated by addition, and it's equal to cosecant of theta. So again, we're taking it from a couple terms down just one term here. So it's basically like simplification. Things we want to avoid, we really don't want, yes, it's an equation, but we're trying to verify that the equation is true. So right now, technically, I guess I should have like a question mark above that equal sign and see, are these two things actually equal? We don't know that. So we can't really use that property of equations where you do like the same thing to both sides because we're not sure this is true yet. We're actually, maybe I'll just write that here for this one. We're trying to verify that they are equal. If we don't know two things are equal, we can't use those equation properties. So we shouldn't be like subtracting things over to this side and trying to simplify this then to look like that. I mean, it's not quite right. What we really want to do is manipulate just one side, normally the left-hand side, okay, normally left-hand side, manipulate that down to look like that cosecant of theta. Okay? So, if we look at what we've got here, right, we've got sine theta plus cosine theta times cotangent theta. So, again, following one of our typical strategies, the first thing we should try and do is rewrite in terms of sine and cosine. Maybe that will help. Okay, so let's rewrite in terms of sine and cosine, which means then, right, that sine of theta will stay sine of theta, cosine theta is going to stay cosine theta, excuse me, but cotangent theta, right, that's going to be cosine theta over sine theta. And again, we'll just put like a little equal sign there. Okay, that didn't really help, did it? Like the cosine theta here is not going to cancel out that sine theta like we're used to. But let's just kind of keep following this here. So let's see, if we continue trying to put this together, I will multiply the cosine theta times the cosine theta over sine theta, so I get cosine squared theta over sine of theta, like that. Okay. Zoom in some more here for you all. Okay, and that's about the best we can do, right? Cosine squared, we see that there, so maybe a Pythagorean identity. So one thing I do see here is we have two terms, right, separated by addition. We have two terms separated by addition, whereas here we have one term. So perhaps what we should do, in fact what we should do here, is combine these two terms together. But in order to combine these two things together, what do I need to get? Common denominator, right? Okay, common denominator here. So what's our common denominator going to be? What denominator do I need here to be able to add these two things together? This needs to have a denominator of what? Sine of theta. So to do that, we'll multiply this by sine theta over sine theta. Right? Just this little piece. Okay. And again, that's okay because when I multiply sine theta over sine theta, I'm really multiplying by 1. So I can just kind of multiply that in there. And so I end up with sine squared theta over sine of theta plus cosine squared theta over sine of theta okay, which, when we put those together, we get sine squared theta plus cosine squared theta over sine of theta. But what is sine squared of theta plus cosine squared of theta? What does that equal? 1. And what does 1 over sine of theta equal? Cosecant theta. So check. They are equivalent. Okay. Question on any of that? Alright. So, what if we had gone back to this step here? And what if instead we had tried to use some sort of like Pythagorean identity here? So let's go back to that step that we had, sine theta plus cosine squared theta over sine theta. What if we did that? What if we saw, oh, cosine squared theta, Mr. Widmeyer said, when we see that cosine squared, that's potentially one of those Pythagorean identities. If I look here, okay, at my Pythagorean identities, if sine squared theta plus, or sine squared x plus cosine squared x equals 1, then cosine squared by itself, if I manipulate this around some here, cosine squared is equal to what? If I were to manipulate this equation around to get just cosine squared by itself, what would it have to equal then? 1 minus sine squared, right? And so what if I did that? What if we did that instead here? What if instead we were like, you know, thinking it differently, and we're like, oh, okay, cosine squared, that's 1 minus the sine squared of theta over sine of theta. Well, this will work too. Watch. I mean, we can still have the sine of theta here. We can break up our numerator over our denominator. So 1 minus sine squared theta all over sine theta is the same thing as 1 over sine theta minus sine squared theta over sine of theta. Okay. But what would sine squared theta over sine theta simplify to be? If you have sine squared divided by sine, what will that be? What's sine squared divided by sine? It's going to be sine again, right? If you have x squared divided by x, it's just x, okay? So sine squared theta divided by sine theta equals, and we have a positive sine theta and a negative sine theta, so they'll cancel. We're left with 1 over sine theta, which again is equal to cosecant of theta. So there's more than one way to do these kind of problems. Okay, there's more than one way to do these kind of problems sometimes. All right. So don't fret, right? If you're like, how am I supposed to know what to do? Well, you try something and see if it works. Again, rewriting in terms of sine and cosine is going to be a huge help to you. Okay, huge help. And then from that point, you do have to do. I mean, you're going to have to wrestle with it a little bit. That's all I can say. You have to wrestle with it a little bit. You know, just try something. Okay. And see what happens. Okay, again, we saw here we had 2 terms and we wanted to get down to a single term. So was there some way I could combine those together to get a single term? That kind of helped guide us too. You can have your eye on the goal there to help you know where you want to go, okay? But you shouldn't be changing this. Bless you. Keep that the same. All right? So questions on any of that? We're not going to do 2 versions of each one of these that I'm showing you, but I just wanted to show you that there's more than one way to go. So, all right, let's try another one here. let's do secant theta minus tangent theta, that quantity, times the cosecant of theta plus 1. And we'll say that that is equal to cotangent. We want to show that that's equal to cotangent theta. Bless you. Thank you. Okay. So, ideas here. What should we do for this one? Any ideas about where we should start or how we could start this maybe? Again, we want to try and just work on that left-hand side to make it try and match the right-hand side here. You could, if you wanted to take the right-hand side, try and make it match the left-hand side, but typically that's not the way we want to go. We want to take that left-hand side and see if we can manipulate it around to get the cotangent of theta there. So, again, any ideas here about what to do? What would be a good first step, you think? Yeah, Nick? Okay, and we do that for everything else, just change everything to sine and cosine? Yep, okay, so that's a great first step, 1 over cosine theta. Minus, and then tangent theta would be sine theta over cosine theta. Cosecant is 1 over the sine of theta, and then plus 1. Okay, so again, that's what we've got now. Other ideas here? What else could we do? Let's go to first step. What do we think next here? What do we think? What could we do here? Okay, we want to get just a single term eventually here. We want to get down to a single term. Cassie?
I don't know if this is right, but because there's already a constant,
put it together? Okay, let's do that. So let's rewrite this as then 1 minus sine theta over cosine theta. Now in the second term there, we don't have common denominators, right? But we could get it, right? We could make that 1. So let's go ahead and just do that. This is going to be, I'm going to rewrite it here so that way I can save some space. So this is, 1 is really then just sine theta over sine theta, we'll say. So then this becomes 1 plus sine theta over sine theta. Okay, so again, I just got a common denominator for the second, kind of thing here to change the 1 to sine theta over sine theta. So it's 1 plus sine theta all over sine theta there. By the way, there's more than one way to do this problem, so if you tried it a different way from the very first step, if you tried it a different way, there's other ways to do this. This is one way to go. So far, so good. All right, now what should we do? Now what can we do? Or now what should we do? What do we think here? What should be our next step? What do we think? We got common denominator for here, common denominator for here, and now we're multiplying. So we don't need a common denominator between these two things. We can just multiply if we need to here. So what should be our next step? Yes, Anna. just multiply. Okay, Anna, we'll try that. I don't know. All right, cosine theta, sine theta in the denominator. That's easy enough. And then to multiply these two in the numerator, what do we need to use here? We're going to have to use FOIL, all right? Or, we're multiplying two binomials here. So we'll have to do the first, right? 1 times 1, 1. The outer, 1 times plus sine theta is plus sine theta. The inner, minus sine theta times 1 is minus sine theta. Oh, the middle term's going to cancel. We have plus 1 sine theta and we have minus 1 sine theta. So the middle term cancels, and it's left with then minus sine squared theta, like that. Okay. Now what? Now what can we do here? Anna? Yeah, right. We just talked about, we just used this, I think, in the last problem, right? Cosine squared is equal to 1 minus sine squared. So we can rewrite that as cosine squared. Okay, is that helpful? Can we do anything from this point? Yeah, Cassie? Yeah, exactly. We have cosine squared here, so that'll just become cosine to the 1. The cosine theta cancels there. We're now left with cosine theta over sine theta, which is cotangent theta. We got it. Okay, there it is. Okay, so we verified it is true. All right. Did anyone FOIL this from the very beginning? Anyone try foiling this from the very beginning? It would work if you did it that way too. So if we did like, secant times cosecant plus 1 secant minus tangent times cosecant minus tangent, it would actually work that way too. If you actually FOIL it from the very beginning and then turn everything in terms of sine and cosine, things would cancel, you get a common denominator, all that good stuff. This is one way. There's another way to go too. So multiple options here, as long as you're doing things that are, mathematically correct, you should end up with where you're going. I don't know which one you get. Questions on that one at all? We're going to do another one here. Okay. Alright, how about... Wait a minute, is that what I... Yeah, okay, that's the one, okay. Alright. Next. Same directions, just verifying. 1 over tangent of x plus cotangent of x. And we want to verify that that equals sine of x cosine of x. Ideas here? Cassie? Oh, change tangent, you mean? Wait.
Oh, I wrote it down wrong.
Oh, okay. But yes, that's the idea. We want to change tangent, cotangent in terms of sine and cosine. Same idea. So tangent is sine x over cosine x. Cotangent x is cosine x over sine x. Okay, now you might be thinking to yourself, that does not look better, that looks worse, right? That doesn't really help. But we do want to add these two fractions together. To add the two fractions together, we need to get a common denominator. So what's this fraction missing here in its denominator? A sine. So we'll multiply by sine x over sine x here. And what's this fraction missing in its denominator? Cosine. Okay, so we'll do that. We end up with 1 over sine squared x plus cosine squared x all over sine x cosine x. Okay, but what's sine squared x plus cosine squared x? 1. So this is 1 over sine x cosine x. Okay, so taking that number 1, dividing by the fraction 1 over sine x cosine x is the same thing as taking this 1 and multiplying by the reciprocal sine x cosine x, which is equal to sine x cosine x. Check. Excuse me. Okay. Alright, do one more, and then we'll have you guys try one here on your own. Alright, so 1 over 1 minus sine theta equals secant squared theta plus tangent theta secant theta. Okay. 1 over 1 minus sine theta equals secant squared theta plus tangent theta secant theta. Okay, make sure I have that one set up right there. Okay. And again, in this case, I would recommend that we still stick to that idea of taking that left-hand side and trying to manipulate it to look like the right-hand side there. Okay. So the left-hand side, it's already written in terms of sine and cosine, so that's not super helpful. It almost looks like, this almost looks like a Pythagorean identity, right? It almost does, but it doesn't have sine squared there. Can we fix it to make it the Pythagorean identity, though? Can we make it, can we fix it to make it 1 minus sine squared? Can we fix it? And if so, if we can, how? How will we do that? What do we need to multiply? Anna? There you go. Exactly right. If we multiply the top and the bottom by 1 plus sine theta. Okay, if we multiply the top and the bottom by 1 plus sine theta, that's that difference of squares idea, right? We have a plus b, a minus b. And so this denominator is going to become 1 minus sine squared theta over, or sorry, 1 plus sine theta on top. Okay, but what does 1 minus sine squared theta, what does that denominator now equal? What's 1 minus sine squared theta? Cosine squared! I heard it, so we're going to go with it. Did that help? Is that useful? Well, if we break up our numerator over our denominator, we now have 1 over cosine squared theta plus sine theta over cosine squared theta. Well, 1 over cosine squared theta, there's our secant squared theta, there's our plus. But then what about that sine theta over cosine squared theta? How does that equal tangent theta over secant theta? Well, let's break up our numerator. Our denominator. Isn't sine over cosine squared the same thing as sine over cosine theta times 1 over cosine theta? Right? Isn't this the same as that? It would be. Sine over cosine, tangent theta. 1 over cosine theta, secant theta. Ta-da, we got it. Okay, so check. It's true. That one I would say is probably the trickiest one because it's not so obvious to see that we want to get that Pythagorean identity there. But that would be the idea. Okay, let me give you one to try here. Alright, so you all try this one here. Sine theta over 1 plus cosine theta plus a cotangent theta excuse me, equals cosecant of theta. Verify that that's true. Multiple ways to do this, multiple ways to go about doing this. I can see at least 2. Go ahead and try and verify that. While you're doing that, I'll pass out your homework. But I wouldn't. Why would you want to do 1 plus cosine? You want to do 1 minus, right? Yeah, so I would just go that route. Yeah. If you, this is the second one. This is much harder than the first one. Not that I'm saying that you need to play easy. This one, they introduce a lot of microtransactions. Yeah. No, I found this much harder. The first one is much more, simple, and you don't have to pay money. I don't think you can beat it without. Yes. You got how far? Oh, right here. Okay, so I have 2 fractions here, and we have 1 term here. So it looks like we maybe should try and combine the 2 of these together, yeah? So we need a common denominator. So that's one option. What do we missing from this denominator? What is this one? So we need to multiply each fraction by those things. So. Okay. Again, if you feel like you got it, if you got it, I guess you got it. You know you got it because you know what the goal is. So. Okay, so here's your start. Right. Okay. 2, 3, 3. So my recommendation, I think here's here you hurt yourself. Because the idea is, right, remember your goal is to get a single term. Okay? And so by not putting these two things together, this fraction together, and then starting to simplify the individual fractions, I think you put down a wrong path. You see what I'm saying? You have a common denominator now. So put the numerators together, and then well,
oh my god.
let's see.
How did you do it? Oh my gosh, look. That's what I was doing.
Oh, what happened to your...
Oh no, I wasn't doing that.
So, you had... Yeah. So, bring, I would say, you want to bring that as well. Minus cosine times 3 plus cosine. Now you're going to have 1 over sine, what's sine over sine squared? 1 over sine. Okay. Yes. Right here? Oh, sure, this is the right one. Okay, yeah. Okay. May I see your pencil? So we want to be careful with this. I think this. Like that, because when you multiply sine theta by the denominator, it's times the whole denominator. So it'll be the same kind of deal here. That's all. Just to show that with the trim you needed it. So then here, when you multiply cosine times 1 plus cosine, it's actually cosine theta plus cosine squared theta. The cosine distributes both sides. Oh, okay. See what I'm saying? Now when you combine your like terms, so this is your next step right here. So this would be 1, this would be cosine theta, and this is going to be those no, because that's cosine squared. But what's cosine squared plus sine squared? That's identity. It's 1. Okay. Right? So this is then equal to cosine theta plus 1 over. Okay, now, you have cosine theta plus 1 over 1 plus cosine theta. They're the same, right? So they cancel, so it's 1 over sine theta, which is... Alright, so you're almost there. Just like the little thing. And again, that wasn't your misunderstanding. That was just like you just forgot to distribute. That's all. I mean, so again, you keep doing correct mathematical things, and you will kind of all the math will kind of almost lead you to that. So, no, that's pretty good. Cool, and then again, folks, once you finish this one, if you want to ask me a question or something, I come around and help. Otherwise, you know.